In Chapter 2, we're going to take a closer look at linear equations, and we're going to start to graph them. In particular, we're going to be looking at numbers that show a relation and numbers that specifically are a function. So let's start looking at these terms. A relation is a mapping or pairing of input values and output values. I'm going to be interchanging a lot of words. These input values are called my domain, and my output values are called my range. So again, looking at this, and it says a mapping or pairing, so I'm going to map them to start with. I'm going to have my domain values here and my range values there. Domain is also my input, and my range is also my output. So again, I'm using these words to describe these numbers that I'm going to place inside this mapping. I could have numbers like 1, 2, and 3, and we'll map it with, say, 4, 6, and 8. Well, the mapping says that we're going to pair 1 with 4, 2 with 6, and 3 with 8. Now, by doing that, I have created ordered pairs. So I could have 1 pairing with 4, 2 pairing with 6, and 3 pairing with 8. So I've now created 2 ways to represent this relation, 1 in mapping and 2 with ordered pairs. What can I do with this information? I could graph them, but we're not up to that quite yet. A relation is a function if there's exactly 1 output for each input. It's not a function if at least just 1 input has more than 1 different output. Relations between 2 quantities can be represented in various ways. There's the mapping that I just highlighted. There's the table of values, a function table. The graphs can show this relationship as well as equations and verbal descriptions. And to this, I actually am going to add the coordinates or ordered pairs. All of these are ways that I can represent a relation or a function. So again, looking at some sort of relation. We'll start with the mapping. In mapping, again, I may have values like 1, 3, and 5, and let's say 2 and 4. Well, 1 is paired with 2, 3 is paired with 2, and 5 is paired with 4. This now is a mapping that leads me to these ordered pairs. And it says that if each input value has exactly 1 output, 1 goes to 2, 3 goes to 2, 5 goes to 4, then this is also a function. But that second statement says that if at least 1 quantity in the input has a different output, then it's not going to be a function. Let's take a look at a second example. And suppose I have 2 and 4, and we'll say that this goes to 5 and 6. Well, 2 goes to 5, 2 goes to 6, and 4 goes to 6. So I'm going to write those as ordered pairs, 2 to 5, 2 to 6, and 4 to 6. We're looking at these input values or the domain values. When I see that 2 has 2 different possible outputs, it's not a function. So I'm concerning myself with what's in this first mapping group, or my x values. If an x value is repeated, or a domain value is repeated, it has to have the same output in order to be a function. So if I input a value of 2 and I get another number out besides 5, it's not a function. Here are these words again that I'm going to be using a lot that we want to get very familiar with. Other words that represent my x values are my input, my domain, and my independent variable. My y values are my output, my range, and my dependent variable. So I'm giving you a lot of background information today. Let's take a look at an actual function. In this function, I'm now looking at it as an equation. In this, whoops, I changed slides. Okay. In this equation, y is equal to 2x minus 1, it states a rule, and that rule says take a number, multiply it by 2, and then subtract 1. So again, I'm creating what we call a table of values. My x values, I'll say, will be -1, 0, 1, and 2. The x values are my domain, so I can quickly fill those right in on this list here. Those values go in my first grouping here, -1, 0, 1, and 2. I now have to get my y values. Now, I mentioned that the x values were independent variables because I can choose any value of x. But y depends on what value of x I pick because I have to now put it into the rule. I'm going to take one number at a time and substitute it in. I'm going to have 2 times a -1 minus 1. Well, -2 minus 1 will give me -3. Let's try it again with 0. Input 0. 2 times 0 is 0, minus 1, -1. Let's input 1 this time. Input, output. We're going to multiply by 1. 2 times 1 is 2, minus 1 is 1. And then I've got 2 times 2. Input 2, that's 4. 4 minus 1 is 3. I have now created the function table. I've found my range values or my y values by following the rule. I can complete now my mapping. And I see that -1 goes with -3, 0 is paired with -1, 1 is paired with 1, and 2 is paired with 3. I can also write these as ordered pairs. -1 and 3 are paired together, 0 and -1, 1 and 1 are paired, and 2 and 3 are paired. And the very last thing I will do with that is graph them on a coordinate plane. And because this is linear, meaning first degree, it's going to form a line on my coordinate plane. We should always be able to identify our domain and range, which is our input and our output. Now we're going to get into talking about graphing them, but I think I'm going to hold off on that for next class. We're going to talk a little bit about the coordinate plane and how we can represent those ordered pairs on a coordinate plane. So I'm going to leave you with that for today, and we'll pick this up next class.